Okay, this video we're going to look at analytic geometry. We're going to start with the straight line. So first let's look at straight line segments. So straight line segments. Okay, we're going to look at the case of a straight line of finite length. So if you imagine we have a straight line from A to B, imagine that the coordinates of B are x2, y2, y the coordinates of A here are x1, y1. We're going to resolve this into horizontal and vertical components. So this vertical length here is going to be given by y2 minus y1. The horizontal component is going to be given by x2 minus xy. So then the length of AB by Pythagoras is going to be AB squared equal to x2 minus x1 all squared plus y2 minus y1 all squared. Then taking square roots on both sides tells us that the length of the straight line from x1 y1 to x2 y2 is going to be the square root of x2 minus x1 all squared plus y2 minus y1 all squared. And then the gradient of the straight line segment from A to B is going to be the difference in y2 minus y1 over the difference in x. Now the angle of inclination theta, which is the angle that the line is going to make with the horizontal axis, we can write in terms of, so if you want to think of a formula involving theta, the adjacent and the opposite, it's going to be the tangent formula. So it's going to go like tangent theta is the opposite of adjacent, but we already have opposite of adjacent here. So that means with this formula we can connect it to the angle of inclination like that. So M is going to be the tangent of theta. Alright, now let's look at some equations of the straight line. So the first equation that we're going to start with is the so-called the standard form. So the standard form equation of the equation of the straight line says y equal mx plus c, where m is the gradient and c is the y-intercept. So if we have a straight line going through 0c with gradient m, then its equation is going to be given by y equals mx plus c, which is called the standard form. Then next we have got what we call the 1-point form. So the 1-point form of the equation of a straight line says y minus y1 is equals to m into x minus x1. y minus y1 m into x minus x1. So this is the equation of a straight line. Again, its gradient is m, but this time we know just one point through which it goes, and that point is x1, y1. So the gradient is still m. Then there is what we call the general form, the equation of a straight line. So the general form, so that one is given by ax plus by plus c equal to 0. So this one is obtained by bringing everything to the one side and possibly clearing fractions as well. So a, b, and c are nice and nice integers. Okay, then let's talk about parallel and perpendicular lines. Parallel and perpendicular lines. Okay, well, two straight lines with gradient m1 and m2. So these are going to be parallel if m1 is equal to m2. These lines are going to be perpendicular if m1, m2 is -1. These lines are called oblique. If none of these two occur, these are oblique. Otherwise, so if neither m1 equal to m2 nor m1, m2 equal to -1, okay, then those lines are going to be intersecting at an angle different from 90 degrees. Okay, there's one more form. I think what we have done so far will be familiar to most of our students. But the next form of a straight line, which is called the normal form, is most probably going to be new to most people. So the normal form of the straight line is given by x cosine omega plus y sine omega minus p is equal to 0. So the angle omega is the angle made. So we've got a straight line like this. If the distance from the origin to the line, this is the normal distance, this is p, and then the angle made by that line is omega, then that is going to be the equation, this one here. So if this is omega here, is going to be 90 minus omega, so that means that's going to be omega there. This one again is going to be 90 degrees minus omega. So if we take this to be 0c and take this one to be b0, so that means the distance from the origin to this point is c, and the distance from the origin to this point is b. Then we can write c and b in terms of p and omega. If we take this triangle, for instance, then we can see that sine omega will be p over c. So p over c is sine omega. So this is telling us that c is actually going to be p over sine omega. Then from this triangle here, p over b is going to be sine 90 minus omega. So p over b is sine 90 minus omega. But sine 90 minus omega is simply cosine omega. So from here we can see that b is going to be p over cosine omega. Then one last thing, the gradient of this line. So if we do c minus 0, then we do 0 minus b, so it's going to be minus c over b. But c is here, is p over sine omega, and then the inverse of b gonna give us cosine omega over p. So this is minus cosine omega over sine omega. So then we can plug this into our equation y equals mx. So we're going to have y equal m is negative cosine omega over sine omega times x, plus c simply p over sine omega. So p over sine omega there. Then if we multiply everything by sine omega, we're going to have y sine omega is negative x cos omega plus p. Then if we bring everything to the one side, we're going to have x cosine omega plus y sine omega minus p equals to 0, which is that equation we started with there. All right. So before we go on with some examples, so notice that this equation is just x times a constant plus y times a constant minus a constant. So it's actually very similar to the general form of the equation here. It's x times a constant plus y times a constant plus a constant. So we're going to talk about how to convert from the general form to normal form. So if we've got ax plus by plus c, we convert to the normal form by dividing by. So we're going to divide by plus or minus square root of a squared plus b squared. The sign is going to be taken to be opposite to that of C if C is non-zero. If C is 0 but B is not 0, then the sign is going to agree, taken to agree with that of B. Agree with B if C is 0 but B is non-zero. Or it's going to be taken to agree with that of A if C is equals to B is equals to 0 but A is not 0. Alright, so that's going from the general form to standard form. Okay, so let's look at 2 examples now. Okay, in this example we want to find the directed distance from the line 3x minus 4y plus 20 equal to 0 to 8 and minus 1 minus 3. The thing we should have mentioned when we talked about the normal form of the equation of a straight line is that if you want the perpendicular distance from the straight line to any point, then you simply plug in the coordinates of the point in the normal form of the equation, and that gives you the distance. So in this case, for instance, we have the straight line 3x minus 4y equal to plus 20 equal to 0. Just for the sake of a sketch, m for this line is going to be 3 over 4, which means it's upsloping, and y is going to be 5. Sorry, not y, c is going to be 5. So that means this line is going to go something like this. This is 0, 5. So so 3x minus 4y plus 20 equal to 0. So of course this is in general form. So we're going to cast this in normal form. So 3x minus 4y plus 20 equal to 0. A is 3, B is negative 4. So this is going to be square root 25. So this is going to be 5. C is positive, so that means we're going to take this to be negative. So that means the normal form of this is going to be obtained by simply dividing everything by negative 5. So that means we're going to have 4 over 5y minus 3 over 5x minus 20 over 5 is 4. So this now is the normal form. Okay. Then to find the distance from this line to 2, 8, the normal distance, so that is the perpendicular distance. So if I just extend the sketch here, so if that's 0, 5, can imagine that 2, 8 is going to be, say, somewhere there. Okay, it's just a sketch. So the perpendicular distance is going to be something like that. Then negative 1, negative 3 is going to be somewhere there, and then again perpendicular distance is going to be that. So for a distance from 2, 8, we're going to obtain by simply plugging 2, 8 here. So it's going to be 4 over 5 times 8 minus 3 over 5 times 2 minus 4. Okay, and then we simply punch this in the calculator. It's going to be 40 minus 6 and then minus 4. Alright, so we've punched this in the calculator. 40 over 5 is actually 8 minus 6 over 5 minus 4. So it's going to be 14 over 5. So that's going to be the distance, the normal or perpendicular distance from the straight line to that point there. Then you can do the same thing with for the other point. This time we're going to substitute minus 1, minus 3. So distance from minus 1, minus 3 is going to be 4 over 5 times minus 3. 3 over 5 times minus 1 minus 4. So this time we're going to have minus 12 plus 3. So minus 12 plus 3 is minus 9. So we're going to have minus 9 over 5 minus 4. This is going to give us minus 29 over 5. So the fact that this distance is negative tells us that this point is below our given line, and this one being positive tells us that that point is above our straight line. Okay, so let's look at another example. Alright, so this time I want to show that the line 8x minus y is tangent to the circle with center at 5, 1, passing through minus 2, minus 3. For this example, it's going to be useful to make a sketch. So in the sketch, we're going to have the circle centered at 5, 1. So imagine that that is 5, 1, passing through minus 2, minus 3. Okay, and then want to prove that the line 8x minus y plus 26 is a tangent to this circle 8x minus y plus 26. So all we need to prove really is that this distance is equal to that distance there. So first thing we're going to do is to find the distance from 5, 1 to minus 2, minus 3, which is the radius. And then we want to need to prove that from this to the point of tangency, which is basically the normal distance from the line to 5, 1, is the same as the radius. So for the radius, we're simply going to do square root of 5 minus negative 2 squared, and then 1 minus negative 3 squared. So this is going to be 7 squared plus 4 squared. It's going to be 49 plus 16. It's going to be square root 65. So that's going to be the radius of this circle. Then we're going to need to find the distance from the center to the line, the perpendicular or the normal distance. So that we can find by first converting this equation to normal form and then plugging in the coordinates 5, 1. Okay, so we have got 8x minus y plus 26 equals to 0. We are going to divide this by the negative, because this is positive, of 8 squared plus negative 1 squared under root. So this is going to give us 8x minus y. I think this is plus 26. Yes. So plus 26 there, all divided by negative square root 65. Then this distance here, let's call it d, is simply going to be given by, so we're going to do 8 times, we're going to plug in the coordinates of the center, which is 5, 1. So 8 times 5 minus 1, and then plus 26, all divided by negative square root 65. Here we are not interested in the directed distance, we just want the undirected distance, so we can actually take the absolute value of this. So 8 times 5 is 40. 40 plus 26 is 66 minus 1. So this is 65 over square root 65. Take the absolute value, which is going to be the plus, which is simply going to be square root 65. And this is equal to the radius, okay, which is equal to the radius, and hence the line L is a tangent to the circle. Okay.